I came up with the idea of combining the fact that we know the molecule phosphine is a biomarker on Earth with the fact that it's been suggested that there are possible habitats in the cloud decks of Venus, so somewhere where little life forms could live free floating. And also the third idea that we could go out and search for the molecule phosphine using radio telescopes. So I put all those together and then gathered a team that could do the various parts of the project. Scientists from all sorts of different disciplines, not just astronomy, but also biochemistry and atmospheric chemistry and lots of other things.
So the fact that we found it there means there must be something producing it. There are a few processes that can produce it, but most of those known processes won't produce anywhere near the amount of phosphine that we've found. So we're left with the conclusion, either there's a process we don't understand at work, or a process that we do know that can produce phosphine on Earth is at work, and that process is life.
So what we did was we went out and used radio telescopes to see if we could detect the presence of the molecule phosphine in the atmosphere of Venus. Venus essentially acts like a giant torch light bulb in the sky. But if you look at a very specific wavelength, a little bit of that light is missing because the phosphine molecules have absorbed it, and so it's not present. And so what we see is essentially some kind of squiggly line going along with wavelength, nothing there, then a sort of V-shaped dip, that's the phosphine, and then some more squiggly line.
Venus, to quote or paraphrase Carl Sagan, is hell. Its surface temperature is high enough to melt lead. Its surface atmospheric pressure is about 600 times the atmospheric pressure at sea level on Earth. A place less favourable for the existence of life than the surface of Venus can hardly be imagined. However, we're not talking about the surface of Venus. We're talking about cloud decks at altitude of about 55 kilometres.
What we don't know is how absolutely feasible it is because of the enormous amount of acid. So on Earth we know of really robust life forms, little bacteria that can exist where there's about 5% of acid dissolved in water, and that's quite an incredible feat. On Venus, the clouds are probably about 90% acid, and that's incredibly corrosive. So we don't really have an easy way to do an experiment to see if a life form could survive that.
So my first reaction on hearing that we'd got a phosphine detection was the classic scientist response of, oh, that's weird. This is how discoveries happen. You look at something and you say, that's odd. Whether it's a spectral line that shouldn't be there or something like pulsars where you're seeing a regular pulse in the radio, and that's odd. And you often find out what's causing it. The possibility that there's some chemical process that doesn't involve life that can do it, that possibility is always there. But of the, as it were, known unknowns that can produce phosphine, the one that's most likely seems to be life.
So the idea of life on Venus is pretty challenging because of the difficult conditions in the cloud decks, the huge amount of acid. So personally, I'm really hopeful. We know organisms on Earth have found some amazing ways to defend themselves. When you think they can defend themselves against being destroyed by radiation and go on to live in nuclear power stations, the powers that they have through evolution are pretty incredible. But we do have to tackle all the other possible natural chemistry routes there might be to producing phosphine on Venus as well. So there's a lot to do, lab work as well as future radio wave observations and spacecraft missions.